Welcome back to another episode of Text Processing and Analysis. In this video, we will look at Stanza, which is a language analysis toolkit, and we will use it specifically for part of speech tagging. Okay, let's get cracking. So the objective of this lesson is that students will tag words for part of speech with Stanza. Like I mentioned, Stanza is a language analysis library, software library, produced at Stanford University. Let's take a look just real quick at their little intro page here. So it's a collection of accurate and efficient tools for language analysis, one of which is part of speech tagging. And so in addition to part of speech tagging, it can do all sorts of stuff. It can return the lemma as well, which will be useful for us. We can get lemmas with the lemmatization function. And it does other things, all sorts of other things. It can do syntactic words of multi-word tokens, head and dependency relations, dependency parsing, named entity recognition, all sorts of stuff that we're not going to see in this class. But we're going to look at it for part of speech tagging. So the steps are the following. First, you install Stanza. So in PyCharm, you would go to the preferences window, or if you know what pip install is, you can pip install. So in PyCharm here, I go up to my preferences window, preferences. Again, in Windows, you would click on the file menu and then settings, and you get to this window. On the left-hand side, you click on project name, the, sixth option down, and then Python interpreter. And here's my interpreter with the associated packages or modules. And you look for the plus sign. The plus sign may be to the right or the bottom or the top of that little window. Then you type in Stanza, one word, and you can see that that's what we want right there. A Python NLP library for many human languages by the Stanford NLP group. That's the one we want. You install it, and after a couple seconds, it should say package Stanza installed successfully. And we say thank you, and we click OK. And then you download the models for languages. And what you do for that is, here are the list of models. They have many different languages. Afrikaans, Ancient Greek, Arabic, Armenian, Basque, all sorts of stuff. Chinese there, Danish there, English. They have quite a few English models there. You can see they have a number of languages available for language analysis. Even Latin as well. Old Church Slavonic. All sorts of good stuff. Russian there. Spanish here. Swedish. Even Swedish Sign Language. Cool. A lot of languages here. Okay. So you download the models for the language you want. Then you create a pipeline object. And the way you do that is very simple. Let me zoom into right in here. So right in this code, let me just zoom in a bit. Right in here. Well, the second line does the pipeline part of it. Okay. Stanza.pipeline with a capital P on the first, and then the 2-character code for the language you want to work with. So for EN, for English, it would be EN. Okay, and then you use that pipeline object to annotate data. Here's an example where they do that. So they import Stanza, they create a pipeline object, and then they pass in some text into that pipeline object there. And then finally they pull out what they want. So they want the text, and they want the universal part of speech tag. They want the pen tree bank tag set there, or tag there. They want some grammatical features there. This is a pretty gnarly double list comprehension here, what they are doing on this line that I haven't read right now. It's pretty gnarly, but what it produces is down below, down here, in this next box down. So you have each word in the text. You have the universal, that U stands for universal POS tag. So this is a proper noun, auxiliary, verb, punctuation. And they also have the pen tree bank tag as well. So that's That's the Penn Tree Bank tag for proper noun. And they have some features as well. They have number equals singular. Here on the verb, they have mood equals indicative. Number is singular. Person's 3, third person. Tense is past. Verb form is a finite verb that is conjugated. Anyway, so I give you a lot of information here. So that's what you do there. And then, yeah, like I said, you pull out the information you want. And there's a gnarly double list comprehension they have there. But that can be expanded out into 2 for loops, which I'll show you. So let's jump right in. Let's have you use all these links I have in my lesson planner. If you just want to get to their website and Google or just poke around their website and figure these things out, you can, or you can click on my links here I have in these steps on the word here, 6 times there. So the first step is to download Stanza in PyCharm's preferences window or with pip install. Now we just did that. I just did that a second ago. So I think we'll just jump right into the next one, which is download the language models for the languages you like to perform part-of-speech tagging on. Okay? So again, using some of my links here, for example, letter B here, do this. Download the language models that you like to do part-of-speech tagging on. Okay? Ready, set, pause the video, and try that. Okay, welcome back. Let's take a look at how I accomplished that. And I do that with, one second, let me double check I saved my last. I want to make sure I save my previous script. So this is how you do it. Right here. So you import Stanza and you say stanza.download and then the 2-letter language code that they have on their website for each language. So if I run this script, keyboard shortcut, and it'll take a couple seconds to load these files. They're somewhat big, 59 megabytes for the English one and 38 megabytes for the Spanish one. And then it's done. So there it is, pretty simple. You import Stanza, then you call stanza.download, and then within quotes, the 2-character language code. If you want to pause the video and make that work on your end, go ahead and do so now. Okay, let's actually do some analysis now. Write a toy language sample that is like a sentence or 2 and print out to the console each token and its corresponding part of speech, both the universal POS tag, the UPOS tag, as well as the XPOS tag, if they're available. They're available in English, but I don't think Spanish, for example, has the XPOS tag. So it can vary by language. But print out a POS tag as well as the lemma. Okay? So again, I would encourage you to click around on these links I have here or just get into their website and look at their documentation and figure out how do you do that. It's just a couple lines of code. All right, so go ahead and write a sentence or 2 and print out the actual token that you write as well as the corresponding part of speech, or both if both are available, the UPOS as well as the XPOS, and then the lemma. Ready, set, give it a shot. All right, welcome back. Let's take a look at how I did that. And I did that right in here. And I do that right there. Let me grab this other option so we can look at that as well. Okay, so what I do is I import Stanza on line 2, which we did before. Here's my little toy language sample, just a simple sentence there. I am Earl Brown. I love teaching students how to analyze language with computers. I create a pipeline there on line 4, so I'm going to call it NLP, some variable name, stanza.pipeline with a capital P at the beginning, and then the language that I want to do the analysis on. And then I pass in the text into that object, and I save it out to some other variable. And then here is the gnarly, well, it's a modified version of the gnarly double list comprehension that they have on their website. So all I want is the text, which is the token itself, like the actual word. And then I want the UPOS, the universal part of speech tag. And then the POS, which is the pen tree bank part of speech tag, and then the lemma. And I do that for each sentence in the document, and I'm looping over each word in each sentence. So this is where the double list comprehension comes in. Let's just see if this works. Keyboard shortcut, ready, set, go. It's going to take a second to load up the models and then run the analysis. And here it is down here in the bottom part of my screen. So I am Earl Brown and I, etc. So here is the U POS tag, the universal part of speech tag. Here is the pen tree bank part of speech tag, PRP, which is personal pronoun. And there's the lemma. And then M has a universal part of speech tag of auxiliary, has a pen tree bank part of speech tag of verb, I think that's present tense, non-third person. And then there's the lemma. So yeah, M belongs to the family of words represented by B. Concordant conjunction there. So that worked. Now I will point out that, like I mentioned in my lesson plan, you can expand this out into 2 for loops. Let me do so. So option 1 on my line 8 is a double list comprehension. But we could do this in 2 for loops. So I could loop over the doc and specifically the sentences in the doc and save each sentence to a variable called like sent. And then within each sentence, loop over the words in that current sentence and save each word to a variable called word. And then I can, and then at that point, within that second for loop, I could pull out the text and the part of speech tags and the lemma. This should give you the same result. I'll run the whole script again. And let's see what happens down here in the bottom part of my screen. And yeah, it gives me the same result, the same idea. So anyway, the double list comprehension on line 8 is gnarly in that it can be hard sometimes to parse out for humans what exactly is happening here with the double list comprehension. And so if it makes more sense, you could look at this double for loop if that's a little easier to figure out what's going on there. Okay, so the only new thing here, let's see, what are the new things here? Well, we have some text, right? And we create a pipeline. We pass in the text to the pipeline object. The real new thing is what I do to actually pull out the information and print it out to the screen. Again, line 8 is doing the same thing that lines 11 through 13 are, just in double list comprehension on line 8 versus 2 for loops on lines 11 through 13 there. So if you'd like to pause the video and look at my code, you can do so now, or you can look at this in my solution file in the CMS. Okay, let's ramp this up, ramp it up to a full file. So before I just had one sentence that I just wrote into my script, let's have it do it for a full file. How could you do that? It shouldn't be too hard. You just simply need to replace the txt variable with the text of a whole novel as one big string. Okay. So give that a try. Pause the video and try to ramp it up to a full file. Ready, set, pause. All right, welcome back. Let's take a look at how I do that. Grab all of this over to here. So yeah, the only difference, well, there's there's 2 differences here. Is that here on line 4 and 5 is where I pull in all of the text of Pride and Prejudice that is sitting in a text file on my hard drive. I bring it in as one string with the .read method on the file connection right there. Once again, there are like 4 ways to read in text from a file. And I bring in the whole novel as one big string on line 5, and I save it to txt. And then there's one other difference here that I'll point out. In fact, let me let this start running while I'm talking. It'll take like a minute or 2 to run. Let me let that run while I'm talking. What I do here on line 6, previously I didn't specify any processors, but here I'm just going to specify the ones that I need, which are tokenize, POS, and lemma. The reason is because I don't want to load the other ones and have it do all the analysis for all the other ones, like the dependency parsing and other things that I don't need, that I don't want. And it'll make the analysis, the processing time quicker. You can see that it hasn't yet finished. I started it like 20 seconds ago now, and it hasn't finished. And so putting something like this in, just the ones you need in the order that you need them, can speed up the processing time of your analysis. So that's another difference there from before. But the rest of it is the same. That line is the same, line 7 is the same, and line 10, again, is just a double list comprehension of what happens on line 13 through 15 down here. So it's still running, and maybe another minute or less, hopefully it'll finish up, and it should print out the entire novel of Pride and Prejudice tagged for part of speech as well as lemma. That's what I'm hoping it will do here. I'm going to pause the video to let it finish, and then I'll show you when it's done. Okay, yeah, so it took about 2 minutes to run, but looking down here at the bottom part of my screen, you can see that it did. So we got the token did, the 2 different type of POS tags, and then the lemma that it belongs to. So did belongs to the lemma do. And so that looks like it worked. Went through the whole novel. Okay, so if you'd like to look at my code, let me expose the part that's different. The part that is different are lines 4 through 6. 4 and 5 are different. And then I simply added this little bit to line 6 there. Okay, so if you'd like to pause the video and make that work, go ahead and do so now. Okay, let's do something fun with these parts of speech. So use the parts of speech to pull out a linguistic construction of your choice. If you can't think of anything else, maybe try the way construction. That is, she worked her way through college, or he cheated his way through school, or he made his way through the crowd. That type of a construction where you have some verb, you have a possessive adjective, and then you have the actual word way, then you have a preposition. That's what I'm referring to as this way construction. Verb, possessive adjective, the actual word way, and then a preposition. So see if you can do that. You're going to have to look up the documentation for either the universal tag set or the Penn Tree Bank tag set. Okay, so go ahead and give that a try. Ready, set, pause. All right, welcome back. Let's take a look at how I did that. This is a little more involved, as you would expect as we ramp up more and more. But let's take a look at the differences here. So I import RE, so I can use the RE module to do some regular expression finding. This is the same. I read in the whole novel as one string with the .read function on line 7. And then this is the same as well. I create a pipeline object. I only specify the 3 processors that I need. I need to tokenize, then get part of speech, and then get lemma. So that's all I want it to do. And the reason I do that is so it doesn't spend the time to do the other analyses. I pass that into, pass the text into the pipeline object. And then here, I'm going to go ahead and just use the double for loop. I think this is easier. I'm not sure how you do it with the double list comprehension. There may be a way. But I'm going to loop over all the sentences on line 14. And then here, importantly, I'm going to loop over indexes. I'm not going to loop over the actual sentences. I'm going to loop over the, I'm going to loop over the words of each sentence on line 17. And let me rephrase that. Instead of looping over the words, I'm going to loop over the indexes of the words so that I can look 1 word to the right, and then 2 words to the right, and 3 words to the right. So I have a 4-word construction. I have verb, possessive adjective, the actual word way, and then a preposition. And so that's why I need to loop over the indexes of the words, not the actual words. So I'm going to say for I in range to length of the current sentence's words, however many words there are. And then here I'm going to try. The reason I'm going to try is because verbs that are found near the end of the sentence won't have 3 words to the right. And so I'm going to try to grab the current word and save it to a variable called WD0. That's the current word right there on line 23. And then I want the word 1 word to the right on 24. So I'm going to call it word 1, WD1, and then 2 words to the right and 3 words to the right. Okay, so I have 4 words. I have the current word and the next 3 words. And I do this in a try once again because if I'm at the end of the file, there won't be anything to the right. Okay, so then here on 29, this is where it gets a little hairy. But I say if you find a V at the beginning of the XPOS tag of the current word, that is word 0, and that's why I say word 0.xpos. If you find a capital V at the beginning of that tag, and you find either PRP with an actual $sign, that this is the tag for the Pentree Bank, and you have to backslash that before that $sign in the regular expression so that it actually looks for a $sign, not the end of string. So either find PRP $sign or WP $sign in the next word to the right. It's POS tag. So I'm looking at WD1, word 1, whereas before I was looking at word 0, meaning the current word. Now I'm looking at one word to the right. Is it a possessive adjective? And the second word to the right, so WD2, the actual text. I'm not looking at the part of speech. I'm now looking at the text. And I want to see if you have a word boundary and then WAY, that is way, and then a word boundary. And don't worry about capitalization on this one because I want it to find capital or lowercase way. And then the third word to the right, that is the fourth word in this sequence, should have IN in the part of speech tag. That's the part of speech tag for prepositions in the Pentree Bank. If all of these evaluate to true, then I want to see what you find. Just print it out. And then here's the except, so that if we're at the end of the sentence and there aren't words to the right, like we're at the end of the last word in the sentence, then it will continue to the next sentence. That corresponds to this try up here. Okay, so if I run this, I should have been running this the whole time, huh? Let me run this and I will pause the video. This will take a while. All right, so it finished about 2 minutes again. You can see down here at the bottom part of my screen, I have those constructions. There are only 4 apparently in Pride and Prejudice. Pursuing her way along, took their way towards, pursuing his way towards, like your way of. So there you have it. That's how you could use the part of speech tags as well as actual words. So we use 3 part of speech tags there, and then actual word, the actual word way, in order to pull out that construction out of Pride and Prejudice. So if you'd like to look at my screen to make this work, I'm not sure if I can expose all of it at once. Let me see if I back out of, well, it's too small. The real difference happens right here from line 17 down to 33. And if you'd like to look at my solution file, go ahead and do so. But if you'd like to pause the video and look at it here, go ahead. Okay, great. So the last one is, rather than just printing to screen, let's save those tokens out to a file on your hard drive. That shouldn't be too hard. You just simply need to open up a file connection and write out rather than just printing, right? So if you'd like to pause the video and give it a try, ready, set, pause. Okay, let's take a look at how I did that. And like I said, there's not much to change here. Let me just grab it and put it in here. I'm going to run it immediately so I can get going, and then we'll talk about it. So the only difference really happens right here. So after I analyze the text with the pipeline object saved to the variable NLP, and I save that result to docs, then I open up an out file connection on line 13. And I'm just going to save it out to my downloads to a file called results.txt. I'm going to write out, save it as UTF-8 encoding, save that variable as out file. And then I have to indent all the rest of the file. The script needs to be indented one to the right so that this file connection stays open the whole time that it's working through the sentences. And all this is the same in through here. This is all the same. So then the next difference is right here on 32, where rather than printing, I write. I say outfile.write, and then also importantly, I add a \n on the right side of that string in order to create a new line break in the file. And I do that with this F string there. Okay, let me zoom in a tad bit on that. So yeah, I'm using F string, and what that is a way to interpolate or put into a string a value. And so I'm saying, give me the text of word 0, that is the current word. Give me the text of the previous, or excuse me, the next word to the right, and then the text of the second word to the right, and the text of the third word to the right. So text here, the dot text is the actual token, the actual word, not a POS tag, not the lemma. And then a new line break. And still working down here. I'll go ahead and pause the video for you and turn it back on when it's done. All right, it has finished. And it didn't print anything out here, right, aside from Xcode 0, which is good news. But if I go out to my downloads directory and look at results out here, I do see those same 4 constructions out here in this file. So that worked. So if you like to pause the video, I'm not sure if I can get everything. Yeah, it gets really small. The new thing is line 13, where I open a file connection, and then I indent all the rest of the script. And then rather than print here on 32, I actually just write out. So I'm not sure if I can get all of it on the same screen. Yeah, there we go. 13 and 32 are new, or different. Or you can look at my solution file as well. Okay. All right. So at this point, you should be able to tag for part of speech with Stanza within Python. And as always, I'm super happy to help. If you get stuck, come into my office hour or that of my TA. All right, see you later.